Welcome everyone. Now we are going to talk about the machine language and binary. In this video, we are going to get to know what is machine language, what is binary code, binary digits, binary numbers. Okay? And you will also get to know what character encoding is. Okay? So let's get started. First of all, the machine language. Machine language, it is a specific form of programming language. In our previous video, we stated that machine language is one of the programming language from lowest level to the highest level of programming language, right? Java, Python, JavaScript, those programming languages are considered as the highest level of programming language. The higher the programming language level is, the more it's closer to the human language. And the machine language, it is the lowest level of programming language. It's the lowest level. That means computer understands and executes it directly. As for the highest programming language, the computer cannot understand and cannot execute it directly. It needs some other steps for the computer to execute them. Okay? This machine language, it uses binary code to communicate with the computer and control the computer's hardware. So machine language basically, they are the instructions and the instructions are represented in the binary system. Binary code in the binary system, it is the representation of instructions that are using a series of binary digits. In order to understand this binary code, you need to have some understandings of CPU first, which is the brain of the computer, right? So the CPU, it is made up of transistors, and it can only process the instructions that are written in the binary code. If the instructions are written in the other codes other than the binary code, then the CPU will not be able to process it. Okay? Remember, programming means talking to the computer, okay? And the computer does not understand human language like English or Chinese or any other human language. It only understands the machine language, and machine language are in the binary code, okay? And the binary codes, they include binary digits, okay? Binary digits. Or binary digits are also known as bit. Binary digit, it is the smallest unit of data. It's the smallest unit of data that the computer can process and store easily. Okay? And binary digit, it is the numbering system, and it is made of zeros and ones. Okay? This binary digits made of zeros and ones. And those zeros and ones in the binary digits, they represent two states. So the 0, it represents the off state, and 1 represents the on state. Okay? On and off. If the state is on, that means that binary digit will have the decimal value. But if the state is off for the binary digit, then that binary digit will not have a decimal value. Okay? And the binary number. So binary number, it is a sequence of binary digits. It represents the numerical value in the binary system. If you want to get the numerical value of the binary system, then you will need to know the binary number. Okay. So in binary system, 1 byte is equivalent to 8 bits. Okay. So when you have those 8 bits, the sequence of those bits is a binary number. Okay. And each of those bits, they will have decimal value if the state is on. Okay. And the decimal value of each of those bits, the first bit will have the decimal value of 1, starting from left to right. The first bit will have the decimal value of 1. And then the next bits, they will have the decimal value of 2 multiplied by the previous bit's decimal value. Okay. If all those bits states are on, in 1 byte, if all those 8 bits states are on, then the decimal value of this 1 byte will be equal to 256. Okay. So in another word, one single byte, it can represent 256 different binary numbers. So how did we get this number 256? Let me quickly show you how it's calculated. So if all those states are on, if all those 8 bits are containing the value 1, okay, not zeros but 1, then all those 8 bits, they will have the decimal value. So the decimal value starting from left to right, first bit it will have the decimal value of 1, and then starting from the second bit, each bit is multiplied by 2. Second bit's value will be the first bit multiplied by 2. First bit's decimal value was 1. Multiplied by 2 means it is going to give us 2. And the third bit, its decimal value will be the second bit's decimal value multiplied by 2. Second bit's decimal value here is 2. If we multiply it by 2, then we will get the third bit's decimal value, which is 4. And as for the next bit, its decimal value will be 8. This one's 8, then 16, then 32, 64, and 128. Okay? So those 8 bits decimal values, if the states were on, it would be 1, 2, 4, 8, 16, 32, 64, and 128. And if we sum all those decimal values, we will end up getting 256. That's how 256 number is calculated. That's why we say that one single byte, it can represent 256 different binary numbers. Okay. And here is the comparison from bit to yottabyte. As a programmer, you should know those different terms from bit to at least 2 to terabytes. Okay. So bit is the smallest one, smallest unit. And when you have 4 bits, it is equal to 1 nibble. And when you have 8 bits, it is equivalent to 1 byte. Okay? Starting from byte, when you have 1024 bytes, that means it is 1 kilobyte. And when you have 1024 kilobytes, it is equal to 1 megabytes. And 1024 megabytes, it made up 1 gigabyte. Okay, what is larger than gigabyte? We have terabytes. So 1 terabyte is equivalent to 1024 gigabytes. Okay. And the ones that are greater than terabytes are petabyte, exabyte, and zettabyte, and yottabyte. Okay. So 1024 terabyte is equal to 1 petabyte. And when you have 1024 of those petabytes, then it will be equal to 1 exabyte. And 1024 exabyte will be equal to 1 zettabyte. And lastly, 1024 zettabyte is equal to 1 yottabyte. Yottabyte is the largest one. Okay. And in order to understand how the decimal values are calculated, how the binary numbers are calculated, you need to understand what base 10 system and what base 2 systems are. Okay. So base 10 system, first of all. This base 10 system, it uses the 10 digits. Those 10 digits are from 0 to 10. Okay. And each digit's position, it represents a power of 10. Okay. To calculate the decimal values and binary numbers, the computer does use base 10 and also base 2 those systems. Okay. So when it comes to the base 10 system, each digit's position represents a power of 10. The reason it's called base 10 is because it revolves around the number 10. Each digit's value determined by multiplying it by the corresponding power of 10. Okay. Here's an example. If those are the digits that we have, okay, in this base 10 system calculation, each digit's value, it is determined by multiplying it by the corresponding power of 0. Okay. So starting from left to right, for example, the first digit's number, 6, it is multiplied by 10 corresponding power of 10, which is 0. 10's 0 will give you 6. 10's 0 will give you 1. And if you multiply it by this digit 6, you will get 6. And for the second digit, it is still the same. Okay. This second digit's second binary digit's value is also determined by multiplying it by the corresponding power of 10. So 10's power to the 1 will give you 10. And if you multiply the 10 to its digit, which is 0, well, you will get 0. And it will this calculation will be repeated for the remaining digits. At the end, if we add all those numbers up, its decimal value will be calculated as 22,706. Okay, based on this base 10 system. That's how the computer calculates this number 22,706 by using this base 10 system. And of course, you will not be required to use this base 10 system to calculate the decimal numbers of the binary numbers. It's just for you to know how the computer is using the base 10 system. Okay, and besides base 10 system, we also have base 2 system. Okay, so base 2 system, it is the numbering system that we were talking about earlier. It is made of zeros and ones that represents two different states, the on state and off state. Okay, this is the important one that you need to know. So in this base 2 system, each digit's position represents a power of 2. It is commonly used in the computers and in any other digital systems. Okay. So when you have those bits, let's say we have 1, 2, 3, 4, 5 bits here, okay? And some of those bits have the status on, state that some of those bits states are on, and some of them are off, okay? As long as the state is on, that means it will have a decimal value. If the state is off, then it will not have a decimal value. So this first bit state is on. So starting from left to right, the first bit, it will have the value of 1. And then the next bits, it will have the value of previous bit multiplied by 2. Okay? So first bit's value is 1. If the second bit was on, its value would be 2. And if the third bit was on, its value would be 4. Then the fourth bits will have the value of 8 since it's on. And the fifth bit, it will have the value of 16 since it's on. Okay? So if we calculate all those together, this first bit will have the value of 1. Second bit, since state is off, its value will be just 0. And third bit, since the state is also off, we will have 0. And as for the fourth and fifth bits, we will have 8 and 16. So 16 plus 8 plus 1, those 3 bits will have decimal value. If we add all of them together, we will get 25. Okay, so this is how the base 2 system is calculated. Again, it is still for you to know how it works. Okay, and let's also do this practice right here. Try to convert those binary numbers to the decimal numbers. Okay, so here 3 bits are given to you, and their states are 0. 0 means off, right? First bit is 0, second bit is 0, third bit is also 0. If the state is off, that means what's the decimal value of each of those bits? It is going to be 0. So what will be the decimal value at the end? 0 plus 0 plus 0 will give you 0. And when you have 3 bits, the first and second bits states are on. They do have 1 in it. But the third bit is off. That means the first and second bits, they will have decimal values. We just need to calculate the decimal values of first and second bits. So first bit's decimal value is 1. Second bit's decimal value is 2. So if we add them up together, we will get 3. How about this one? Only the first bit is on. As for the rest of the bits, they are off. First bit will have the value of 1. Okay? And what if I have the third bit that is on, and as for the first and second bits are off? What's the value of the third bit? So first bit is supposed to have the value of 1. Second bit supposed to have the value of 2. Third bit supposed to have the value of the decimal value of the second bit multiplied by 2, which is 4. Okay. And what if only the second bit is on, and as for the remaining bits, they are off? Second bit's value is 2. So you will have 2 here. And lastly, what if all those 3 bits are on? The states are on. First bit will have the value of 1. Second bit will have the value of 2. And third bit will have the value of 4. So if you add them all together, you will get 7. Okay? That's how the binary numbers are converted to the decimal numbers using the base 2 system. And next, let's talk about the character encoding. It is also correlated with the binary codes. This character encoding, it is basically a method. It is a process of assigning numbers to the graphical characters. Okay? Because computer does not understand the graphical characters, so in order to process it, we use character encoding to assign numbers to the graphical characters, and then computer can understand it. Okay? Every piece of data, including special characters or any other characters, every piece of data in the computer is represented in binary codes. Okay? Doesn't matter what character it is, it has to be represented in binary codes in order for computer to understand. And this character encoding is the method of assigning a unique numerical value to each characters in the character set. Okay? So this method basically it allows the computer to store, transmit, and manipulate the textual data. And the character encoding, it was developed in the 1960s. The ASCII was the earliest character encoding scheme. Okay, so this schemes, the ASCII, it stands for American Standard Code for Information Interchange. Okay, in short, we just call it ASCII. This ASCII, it is the earliest character encoding schemes. It defines a set of 128 characters, including the English letters, numbers, punctuations, marks, and any other control characters. Each character was represented by a unique binary code. Since the ASCII was primarily focused on the English language, it had many limitations. It only supported a limited range of characters. Only those 128 characters were supported in the ASCII. So those 128 characters are understood by all the computers in the world first. Okay? And as computers becomes more global, okay? Global means like with the different language, right? Language with the different characters are emerged later on. Okay? So after language with the different characters are emerged, more comprehensive coding schemes was needed. Okay, so eventually it led to the development of Unicode. So the Unicode, it is basically also a character encoding. It is a character encoding standard that aims to support all the language, not only English, all the language and all the characters that are used worldwide. It assigns a unique numeric value to each character, including the characters from different scripts, symbols, or emojis, and many more. It also includes the characters of ASCII. This Unicode also includes the characters of ASCII. ASCII is basically a subset of Unicode. Okay, so that means the first first 256 Unicode characters are identical to the ASCII characters. Okay. And besides this ASCII and Unicode, we also have many character encoding schemes such as UTF-8, UTF-16, UTF-32, etc. All use it to define how to convert a numeric value to the binary code. Okay. And the Java that you're about to learn, Java, it used the UTF-16 encoding schemes. It used the UTF-16 internally, and it supports all the common encoding schemes. Okay. This part we will explain it more in the other modules. When you start learn coding in Java, we will explain this character encoding that Java internally uses. Here is an example of how to use the character encoding. I'm going to give you the example based on the ASCII table. For those who does not know what the ASCII table, the 128 characters that are included in the ASCII coding character encoding schemes, please go to Google and search for ASCII table. You will get this table. Okay. So if I need to do character encoding for the character A, I can go look it up on the ASCII table. On the ASCII table, we do have the decimal number of character A, hexadecimal number of the character A, binary code, and all those informations. Okay. So hexadecimal, it is base 16 numbering system, which is also used by Java. Okay. The UTF-16 character encoding scheme, the one that Java uses, it also uses this base 16 numbering system. Okay. So the decimal number of A on the ASCII table will be 65, and hexadecimal number will be 41. Okay. And binary value of A is this. Okay. And Unicode notification of A will be this Unicode notification. Okay. So as you can see from this recording, first of all, it's challenging to understand this machine language, right? Machine language is a lot more complex and harder to read, and it's not even a little bit closer to human language. Not even a little bit closer to the human language, basically. So that's why we need to learn programming language instead in order to communicate with the computers. Because learning machine language, it is a headache for us, okay? But to understand how the computer works, you need to have basic understandings of machine language, binary, as well as the character encoding, okay? So once you understood the basics of those, then you know how the program, how the operating system operates, okay? How the computer operates. And it's also going to make it easier for you to understand how the program is working. So in our next video, we will talk about how the program works. See you all in the next video.